Super excited to have you guys here to tell you a little bit more about what's happening in Google Maps platform. Hope you had a good keynote down below or wandering through the sessions. We also have some demos down below, so hopefully you get a chance to see that. So I'm Saleem van Groenou. I'm a product manager on the Google Maps platform and the geo-sustainability team. I'm joined by a few of my colleagues here. I've been with Google for 9 years. I've been building impact-focused, action-oriented sustainability products for those years. And this is the culmination of some of our products that we're going to show you today. So I'll tell you a little bit about the environmental category. Then we will spend a little bit of time on the APIs themselves, and we'll have a little bit of time for questions at the end of the time. So let me start with Google sustainability. Google's been focused on sustainability for a long time, especially in our operations, being the first company in 2007 to become fully carbon neutral, to creating, buying the largest corporate renewable energy purchase in 2019 to our current 24/7 carbon-free goals, which are super ambitious. And this work not only leads the industry, but it really helps drive larger systems change. And when you think of Google's expertise and our mission, it's really about making information accessible and useful for better decision making. And so within sustainability at Google, we really think of it as 3 pillars. Of course, on our operations, as I mentioned, but there's also how do we empower individuals, how do we empower our partners, which is why a lot of you might be here today. So addressing climate change is really an information problem in many ways. In fact, in a report that we commissioned in 2022, we found that 20 to 25% of all of the initiatives that the EU needs to do to reach their deep decarbonization goals have some form of digital enablement there. And for individuals and our partners really to drive that positive action for our planet, it really means we need to access the billions of users that use our products every day with things like eco-friendly routing, air quality monitoring, or putting the carbon number next to Google Flights and in the flights that people are purchasing. It also means building new tools and platforms. So in 2010, we launched Google Earth Engine, a geospatial analysis platform really to look at environmental monitoring. In 2018, we launched the Environmental Insights Explorer, a tool focused on bringing actionable data and insights for thousands of cities around the world. But what's really important here is that right now, consumers are interested in sustainability more than ever before. In 2022, searches for electric vehicles, electric bicycles, solar energy reached all-time highs. And people around the world are really interested in, how do I live more sustainability? What's going on here? And that's spurred on by, of course, extreme weather events, local pollution, new incentive programs. It's also by the kind of critical mass of friends and families and neighbors who have either had some impact associated with climate change or maybe have seen the benefits of sustainable behaviors and technologies. And so now, really more than ever before, this is the time when it makes sense for businesses to offer solutions to consumers that can help inform and enable those sustainable choices. Enter Google Maps Platform. Google Maps Platform is really about providing the information to developers based on the most up-to-date, accurate, and constantly evolving understanding of the real world. GMP enables organizations to create amazing geospatial experiences. You've probably seen Google Maps in a lot of different places for their users based on the trusted information that we've been building within Google Maps for decades. And so when you combine these two, one, Google's long-standing commitment to sustainability, and GMP, Google Maps Platform, as a developer platform, that's why we're super excited to launch the environment category with GMP. This is really our first step towards making GMP, Google Maps Platform, I'll keep using that acronym, the leading destination for developers to access unique, hyper-local sustainability and climate data and insights. And today, that's where we are launching 3 new APIs, the Solar API, Air Quality, and Pollen, that you'll hear a little bit more about today. These products apply AI and machine learning to environment data to give businesses helpful information that can inform consumers' daily behaviors, that can help inform purchasing decisions, and can make businesses operate more efficiently, right? Reduce the time and cost of doing business. And GMP, of course, offers the reliability and scale for supporting developers around the world. It offers really an ideal platform for us to partner with developers and bring that information to bear that will ultimately help us address climate change. So let me dive a little bit deeper into solar itself. That's the product I've been working on for a number of years. The opportunity, of course, I have to say this, for solar is brighter than ever. Really, residential and commercial solar in the last year makes up 50% of all the expected growth in solar in 2023. And in 2024, the International Energy Agency predicts that over 150 gigawatts of solar energy will be installed. That is tens of millions of systems around the world. And that's really fueled by policymakers who are setting this great policy environment through incentive programs, especially here in the US and Europe. And it helps get, solar's easy to install, it happens really quick, and it reduces the energy cost burden for individual building owners. So what is this API itself? What we did is we took high-quality imagery and maps data. We used AI models to analyze that imagery to understand the details about the individual roofs, including the slope, obstructions, shade patterns. And then we add in weather to understand what is the solar potential, how much solar energy will be produced by those rooftops. And so in the API, we return it in two different formats. One is the raw data. The raw data is an imagery layer, so you can see the actual house that you're going to be putting solar on. We give you a DSM, a digital surface model, which is an elevation, a pitch, and shape of the roof itself, as well as flux, so sunniness and shade values across the entire year for that building. And then we digest those insights, and we also produce another endpoint, which is really about the insights of the building and solar potential for a specific building that you might be querying. And this, I'll tell you a little bit more about why that's important, but this is key solar information, really at this, I just need a quick hit. What is the solar potential of this building? So the API is based on what we learned from the Project Sunroof tool that we launched in 2015. This is a consumer-faced tool that has helped countless homeowners around the world understand whether solar is right for them. And we were working with industry partners over the last few years to understand what they needed to really accelerate their businesses, drive customer trust, and ultimately deploy more solar. And so with our expanded coverage, with the data and imagery that you need to create accurate and competitive solar proposals, we hope this increases your conversions, reduces your number of site visits, and decreases your site design times for solar installations. The API was designed to support use cases across the entire solar installation funnel, from customer awareness to acquisition to panel layout to design and installation guides. You can use the API to support specific buildings, put a specific building in front of a customer and say, this is your roof. This is, these are the panels on your roof. Solar is right for you. You can take that down a level and put a distinct quote together that says, you need 7 panels on your roof and they're going to be on this corner of the roof. You can create designs there. And then you can create installation guides as well. So you can use the raw solar data to really say, okay, here's my installers need to go to this part of the roof. It's this tall. They need to bring that ladder with them. So it's everything from, I have a portfolio of buildings. Which one's right for solar? We can do that. And it's down to the level of, I need to put panels where. That's what we're really excited about with this tool. So the solar API, we're excited to launch it to 40 countries, covering 320 million buildings. This coverage supports businesses and customers at scale. It helps you it gives you the ability to expand your business into new markets. We're not done though. We know new buildings are coming up all the time. We know that they're interested in distributed solar on residential commercial roofs is not limited to these countries. And we're super excited to hear more about what is needed in the world. Well, how do we help accelerate solar installers even more? So if you have ideas, I'm here to listen to those. But to tell you a little bit more about solar and how it's being used by one of our customers, I want to introduce Bas.
Yeah. Thank you, Saleem. Thank you for having me here. My name is Bas van der Peet, and I will tell a story about closing the gap. But that's what we've been doing the last couple of years. But we're on a mission to help the European Union to achieve 1 terawatt peak of installed capacity in 2030. That's our mission. That's what we're working on and been doing since 2009. To explain that, I have 2 short stories. One about how we grew our company over the last couple of years, and the other about the complexity of the energy market and what it means. We started in 2009. A couple of my colleagues, they looked at certain problems in the spatial planning area, and they also saw a question about solar. and they looked at what kind of data was available and how they could use that. And they saw there was laser scanning data, LiDAR data, which is translated now into a DSM model. And they saw building boundary data, and they started thinking about it, and they had the intuition they could build something of it. And they started with a first algorithm, and for one building, it took over a week to calculate it. Well, the end result was great, but a week then already was too much. So they started improving, and in 2010, we got to the point that we could calculate a complete city within a week and share the results of that in a solar map to a municipality or city so that the inhabitants could see what the potential of the roof was. That was the first start. The main issue was that we needed to have data. The data was not available. It was always only available through a governmental agency. Took a lot of time, a lot of effort. So we started looking for other sources of data. And in 2014, there was a big moment. The European Union had a legislation that made sure that every country should be able to provide the open data. There were two countries who did that, the Netherlands and Denmark. And we had some great results with that. And then we started waiting for the other countries to follow. Didn't happen. And then Google Sunroof project was the next step for us because we saw that that's another alternative. We already had reference data sets which we could use to validate the data of Google, and we saw that it was good for what we wanted to do. So we started with projects in Germany and the UK, doing the same thing again. Then again, before a lot more data became available, it took a lot of time. So some of the countries in the EU gave data available, but still not enough. And then in 2022, the discussion with Google started again, and they decided the Google Sunroof project would become a commercial product, which was a great decision for Google, but also for us in the end. And that led to us launching the 1 terawatt peak initiative this year at Intersolar in Munich, a big solar convention. The other story is about the solar market. And I already had solar panels on my roof in 1996. I don't know, who of you have solar panels on the roof? Can you raise your hand? So still a lot of people to convert to using solar. That's great. But when I bought my house in 1996, it had already solar panels on it because it was part of the deal. So it was not that difficult to buy them. What you see here is the blue line is the complexity of the market in it. And during the last couple of years, the complexity increased a lot. So new products, batteries, heat pumps, if you look at, for instance, the energy contracts that you can get. So the complexity is growing a lot. And the other thing, people trusted the energy market. It was easy to understand, and that trust declined very fast to the point where there's now a gap between the complexity of the market and the trust that people have in that market. And that's what we're closing. We're closing that gap. That's what we're trying to establish. And I have to click through this, yes. Another part is what we saw, so that if the blue line is what kind of data is necessary to give good advice to consumers or to businesses. The initiative in the Netherlands and Denmark made it possible to advise those countries really well on what's possible. In the other countries, it was really difficult. Always small data sets, a lot of work to do the data quality checks. With the availability of the Google Solar API, that becomes a lot more easy for us to do. So we can close the gap now at this moment, but only at this moment. Saleem already said, new buildings will come, new solutions will be there. So it is a challenge to keep ahead of the trust versus complexity of the challenge that we're facing. That's the two stories that converge. What we have done over the years is we have created solutions for governments to educate on the potential of solar, but also for commercial companies to help raise the conversion of their sales processes. Those are the really important things that we've done. And we're doing that now with the new Google Solar API far better, faster than ever before. This is what we have achieved so far in Europe, and we're really proud of that, that we have achieved that. That's really something that every time we look at these figures, we say, wow, but it's still not enough. If you look in the room, how many people already have solar panels? It's not enough. There have to be more. So then what do we have from a technical perspective? We know of each roof part, the tilt, the orientation, we know the size, and we use that to estimate scenarios. what is the best option for your energy consumption or your future energy consumptions. We know what objects are in the neighborhood, and we can use that to calculate how much shadow there will be and how much actually the radiation will hit the roof parts. We know we can create online, real-time, a first indication of a solar plant. It's used in educational purposes and also in commercial situations to help to give the viewer an understanding what is possible. We know the height, and the height of the lowest roof part and also of the highest roof part. The lowest roof part is really important to understand what's the height of the safety measures that you need to take into account. Safety measures are really necessary but also very costly, so explaining that to an installer is really important. We know about the situation around the building, which is important if you look at it from the perspective of the individual who wants to buy a solar plant. Explaining, this is your house, this is what the shadow will do, and this is what the potential installation can be, helps them into making the decision to buy a solar plant. And again, these two stories now converge. What we're trying to do every day, every week, is make sure that we close the gap between complexity and trust, and make sure that our customers, which are municipalities, which are commercial companies, which are individuals, use that data to start using renewables. And that's for me. Thank you for now.
Thank you, Bas. So from here, we're going to switch to the other APIs we're launching today. To tell you more, I'd like to introduce Ron Korber, an environmental engineer who's also the director of product.
Thank you, Saleem. According to the World Health Organization, air pollution is among the greatest environmental health risks which we face today, which accounts for more than 7 million premature deaths every year. Also, due to climate change, there is an increasing growing phenomenon of other environmental hazards, such as wildfires and pollen. This all creates a huge healthcare cost, and according to the World Bank, the cost of air pollution alone is more than $8 trillion annually. In current times, when health and climate change is top of mind for individuals, businesses, and authorities, every consumer experience, every product, and every business process must become climate aware and climate resilient. Which is why we are very excited to introduce the new air quality API and the new Pollen API as part of the new environmental category on Google Maps platform alongside with Solar API. This is all part of Google commitment, making reliable, relevant environmental data available to the masses. With the new air quality API and the new Pollen API, we don't only provide accurate data, but also heat map capabilities, as well as recommendations on how to reduce exposure. And yes, this can all be available with easily to integrate APIs, which can be used on every new or current business applications or websites. Let me tell you more about what is available via the APIs. Air quality is a new capability that provides current and historical data. The air quality APIs provide granular air quality data to help innovate your product and style your map in order to visualize air pollution exposure. This enables people to understand the air they are breathing and making informed decisions, such as choosing the right park, the cleanest park to take the children outside, limiting outdoor stay, or choose where and when to do outdoor activity. Key features include real-time air quality index, which is hourly air quality information available in over 100 countries at an astonishing resolution of 500 meter or 1,600 feet resolution. Also available is a very intuitive air pollution map, which is color-coded representation of the air that we breathe. We also provide other features such as health tips and recommendations, which are hundreds of recommendations on how to avoid exposure based on 7 population segments. For example, recommendation for asthma patients, COPD patients, athletes, and more. Moving on to pollen. Pollen is a natural phenomenon which also have a significant health cost on society, with over 400 million seasonal allergy sufferers globally. In a world where pollen counts are rising and pollen seasons are getting longer and at the same time more unpredictable, there is an increasing demand for accurate pollen forecast. Therefore, the Pollen API is a new capability based on very advanced models that calculate the pollen index for 3 pollen types and for up to 15 pollen plant species. This is available on a 1 by 1 kilometer square grid in 65 countries. And yes, just like the air quality API, Pollen API also include heat map capabilities, which you can display on top of your Google Maps. A variety of industries can use the pollen and air quality APIs, and those industries include smart home, healthcare, mobility, travel, government, media and big tech, real estate, insurance, and more. And I will be happy to give you a couple of examples. In the healthcare market, for example, among our customers are medical companies and pharmaceutical companies. For seasonal allergy sufferers, there are good news because there are treatments that can be efficient in order to prevent or avoid related symptoms. However, these are mostly efficient if taken before allergic symptoms start. So among the use cases, there are apps that provide alerts for seasonal allergy sufferers. So for example, if we see that pollen count might be high at a user location according to a forecast, these apps will warn this user, this patient, in order for him to make informed decision on how to reduce exposure. For example, closing the windows at his home, or even use his personal preventative medicine. It is also no surprise that exposure to air pollution during our daily commute might have a negative impact on our health. So therefore, in the mobility and automotive industry, air quality and pollen data allow for more informed driving decisions. Passengers and drivers can use the data to find alternative routes to reduce exposure. They can also make other informed decisions, such as turn on the in-cabin air purifier in their car. The Air Quality and Pollen API can be easily integrated into the car HMI, as well as a driver companion app. So the driver can make sure the car is prepared and optimized before the journey begins. Next, Emil Fisher, Director of Research and Engineering at Google, will elaborate more on the unique dynamic of air pollution and how we are able to provide accurate environmental data. Emil?
Thanks. Okay, thanks, Ran. So, hi, everybody. Okay, so people sometimes wrongly assume that they are exposed to pollution only when they are located to really next to a pollution source, such as if they are next to a busy traffic jam, or a wildfire. But actually, the reality is a bit different. People can be also exposed to far pollution sources, such as dust storms that can travel great distance and can cross oceans and even continents. Okay, so you can see here a time-lapse video representation of the air quality changes in the Bay Area. You can see how the air quality changes, from one street to another. And of course, you can see the colors. The colors represents, green represents good air quality, which is healthy for everybody. Yellow represents moderate air quality, which can be harmful for sensitive groups, just like asthma patients. And red represents bad air quality, which is harmful for everybody, even for short exposure of time of less than 1 hour. As you can see, the air quality changes dramatically from one street to another, from 1 hour to another, and from good to bad. So, as you can see, this is also very challenging to map the pollution at your exact location, and there are several reasons for that. One is delays in reporting, and also coverage between sensors. Cool. So to resolve this challenge, we are using sophisticated algorithms, and what we are doing, we are fusing multiple data layers. We are taking traffic information, We're taking weather conditions, different models. We're using fire, smoke models, etc., to calculate the pollution in more than 100 countries in a resolution, as Ran mentioned, of around 500 meters, which is around 1,600 feet. This unique approach enables us to provide information even when one of the data sources is unavailable. We calculate the pollution in around 500 million geographical locations around the world. In those locations, we calculate the pollution, the pollutant concentrations of billions of different pollutant concentration types, as PM2.5, PM10s, and others. And overall, we digest terabytes of data. We also support more than 70 different air quality indexes. Basically, those are official governmental global air quality indexes that we can provide anywhere. Also, a similar approach we are taking with pollen modeling or pollen forecasting. We use and fuse multiple data layers, such as land cover, and total production per pollen type, and climate data. And then we're able to provide meaningful information, such as pollen index, which is a universal and global pollen index. We can also provide exposure risks, actionable insights, and heat maps. So you're asking yourself, why now? So according to the World Health Organization, air pollution is one of the biggest environmental health risks. This is why the WHO took a bold action, and in the first time in 16 years, they reduced their air pollution thresholds and updated their guidelines. This creates a lot of sense of urgency among governments, companies, and people. And also, the news coverage about air pollution, pollen, and wildfires changed drastically, and they are now, as you see, everywhere. Also, we see that many world leaders and the CEOs of large companies, they are focused themselves on realizing sustainability. So, I'm really excited to announce the general availability of our new air quality and pollen APIs as part of our new, also, environmental product suite available via Google Maps platform. If your company is looking to bring real value to your users, to increase brand loyalty and trust and increase engagement and help your communities, so the air quality and pollen APIs were created exactly for that, to support multiple business segments across many health-related use cases, that again, to bring real value to your users. Thank you.